Welcome to Sleepy Time Stories. Hello, my dear friends. The question that changes everything. Imagine you could rewind time. Not just a few years, not even a few centuries. Go back 70,000 years. You're standing somewhere in East Africa, watching a group of modern humans, our direct ancestors, preparing to leave the continent.
They look like us.
Same brain size, same cognitive abilities, same capacity for language and abstract thought. Now, here's the experiment. You split them into groups and send them to different continents. One group stays in Africa, another heads to Europe, a third goes to Asia. Others eventually make it to the Americas and Australia. Fast forward to the year 1500 AD. These groups, all starting from the same place with the same biological potential, have developed radically different societies. Europeans have steel swords, ocean-going ships, and written language. They're about to build globe-spanning empires. Meanwhile, many societies in sub-Saharan Africa, the Americas and Australia, are still using stone tools. Some have never developed writing. Others haven't domesticated large animals or built sprawling cities. The question that haunts historians, anthropologists, and anyone who really thinks about it is simple but earth-shattering. Why? Why did human populations, all equally intelligent, all equally capable, end up on such dramatically different trajectories? Why did gunpowder originate in China? Why did the scientific revolution happen in Europe? Why were Native Americans vulnerable to European diseases, but not the other way around? And perhaps most uncomfortably, why do people from different continents even look physically different? Now, before we go any further, let's address the elephant in the room. This topic makes people nervous, and for good reason. For centuries, these differences were used to justify horrific things. Slavery, colonialism, genocide. People invented racist pseudoscience, claiming some groups were simply superior to others, that Europeans were more intelligent, more industrious, more destined to rule. It was all lies, comfortable lies that powerful people told to justify the unjustifiable. But here's the thing. Refusing to ask the question doesn't make it go away. The differences existed. They were real. A Spanish conquistador with a steel sword and smallpox really did have enormous advantages over an Incan warrior, no matter how brave or intelligent that warrior was. The question isn't whether these differences existed, it's why they existed. And the answer, the real answer, has nothing to do with the people themselves. It has everything to do with the land beneath their feet. See, what scientists have discovered over the past few decades is that geography is destiny. Not genes, not culture, not some vague notion of civilizational superiority. Geography, the shape of continents, the animals that happen to live there, the plants that happen to grow there, the diseases that happen to evolve there. Pure accident, pure luck, or in many cases, pure bad luck. If you're using this video to fall asleep, perfect. That's exactly why I make these. So maybe subscribe and drop a comment telling me where you are and what time it is. I love seeing Berlin at breakfast, Tokyo at midnight, Chicago at bedtime, all watching the same story unfold. The story we're about to explore is one of the most important in human history. It explains why Europe colonized Africa and not the other way around. Why Eurasian diseases devastated Native Americans. Why certain physical traits evolved in certain places. And it does all of this without resorting to racist nonsense about inherent superiority. The real story is somehow more fascinating than the myths. It involves continental axes, zebras, that refuse to be tamed, the accident of wheat versus yams, and climate zones that shaped everything from immune systems to skin color. It's a story where tiny geographic details cascade into massive historical consequences, where the orientation of a continent determines where the writing develops, where the presence or absence of a domestic animal changes the entire trajectory of civilization. And here's what makes this story so powerful. Understanding it doesn't just explain the past, it explains the present, why global inequality exists. Why certain regions are wealthy and others aren't. Why your ancestors look the way they did. Why you look the way you do. Most importantly, it reveals something profound about human nature. When you control for geography, when you account for the environmental circumstances, there are no superior peoples. There never were, What looked like evidence of superiority was actually just evidence of geographic luck. Europeans weren't smarter than Africans or Native Americans. They just happened to live on a continent with better starting conditions for developing certain technologies. Think about that for a second. Everything we think we know about why the world looks the way it does, most of it is wrong. The real story has been hiding in plain sight for thousands of years, written in the shape of continents and the distribution of wild plants. Over the next few hours, we're going to unpack this mystery piece by piece. We'll start where humanity started in Africa. We'll explore why some continents gave their inhabitants massive advantages, while others didn't. We'll talk about why you can't ride a zebra, but you can ride a horse, and why that matters more than you'd ever imagine. We'll examine how disease-shaped empires now climate-shaped bodies. By the end, you'll see human history in a completely different light, not as a story of superior and inferior peoples, but as a story of luck, geography, and the compound interest of small advantages over thousands of years. The question that changes everything isn't who was better, it's what was different about where they lived. Let's find out. Here's something that will the African cradle, where humanity began completely reframe everything. You think you know about human evolution. Every single person watching this video, whether you're European, Asian, Australian, or from anywhere else on Earth, had ancestors who lived in Africa. Not some of your ancestors. All of them. This isn't speculation. This is genetic fact, written into every cell of your body. Around 300,000 years ago, the species we call Homo sapiens emerged in Africa. Not in one specific valley or cave, but probably across a network of populations scattered throughout the continent. Recent archaeological evidence suggests early Homo sapiens fossils from Morocco, Ethiopia, and South Africa, all dating to roughly the same period. This tells us something profound. From the very beginning, humanity was diverse, spread out, adapting to different environments within Africa itself. And here's where it gets really interesting. Africa isn't just where humanity began, it's where humanity remained the most diverse. If you took a random group of 100 people from a single African village and measured their genetic diversity, you'd find more genetic variation within that one village than you'd find in all of Europe, all of Asia, and all of the Americas combined. More diversity in 100 people than in billions spread across 3 continents. Think about that for a moment. Let it sink in. This isn't because Africans are somehow different from everyone else. It's because everyone else is a subset of African diversity, a small splinter group that left carrying only a fraction of humanity's total genetic variation with them. It's like taking a handful of coins from a treasure chest. That handful might contain a few different types of coins, but the chest still contains the full collection. For hundreds of thousands of years, Africa was where all the action happened, where humans developed every fundamental skill that would eventually let us dominate the planet. The earliest sophisticated stone tools, Africa, archaeological sites in Kenya and Ethiopia show humans crafting complex tools 320,000 years ago. Not just sharp rocks for cutting, but carefully designed implements for specific tasks. Scrappers for processing hides, points for hunting, blades for butchering. Each tool required planning, abstract thinking, the ability to envision a finished product before beginning work. The first art Africa ochre pigments, ground up and probably used for body decoration, dating back at least 100,000 years, carved patterns on ostrich eggshells. Beads made from shells and carried hundreds of miles inland, suggesting trade networks and symbolic thinking. The origins of language, almost certainly Africa. While language doesn't fossilize, the archaeological evidence for complex social organization, long-distance trade, and sophisticated tool-making all point to people who could communicate detailed information effectively. And by the way, I'd love to know where you're watching this from and what time it is in your corner of the world. Drop a comment and let me know. Are you settling in for sleep in Europe? Just waking up in Australia? Let's see how far across the globe this story reaches. For 250,000 years, human populations in Africa were innovating, adapting, developing the cognitive and cultural toolkit that defines our species. Different groups specialized in different environments. Some became expert fishermen along coastal regions. Others mastered hunting in savanna grasslands. Still, others learned to survive in marginal environments where resources were scarce and competition was fierce. This environmental diversity within Africa created evolutionary pressure for adaptability itself. African humans couldn't specialize too narrowly because the climate was constantly shifting. What worked during a wet period might be useless during a drought. Groups that could innovate quickly, that could share knowledge and adapt to new conditions. Those were the groups that survived. This is why modern humans are so cognitively flexible compared to other species. We're not adapted to one specific environment. We're adapted to adaptation itself. And that happened in Africa over hundreds of thousands of years of climate variability and environmental challenge. Then around 70,000 to 80,000 years ago, something changed. A small group of humans, maybe just a few hundred individuals, crossed from northeast Africa into the Arabian Peninsula. Why they left is still debated. Maybe population pressure, maybe climate shifts that made the crossing easier, maybe just curiosity about what lay beyond the horizon. But they went and they kept going. Within a few thousand years, their descendants had spread along the coastlines of Asia. Within 10,000 years, they'd reached Australia. By 45,000 years ago, they were moving into Europe. By 15,000 years ago, they'd crossed into the Americas. But here's the crucial part. Most humans didn't leave Africa. The out of Africa migration wasn't a mass exodus. It wasn't everyone packing up and abandoning the continent. It was a tiny splinter group. A few hundred people out of a total African population that probably numbered in the hundreds of thousands, maybe millions. Think of it like a few families leaving a large city. The city continues on, diverse and complex, and full of different cultures and innovations. Meanwhile, the families who left start a new settlement somewhere else. That new settlement will only contain the genetic and cultural variation carried by those specific families. Everything else, all the diversity that existed in the original cities, stays behind. This is why genetic diversity is so much lower outside Africa. The founding population that left was small and carried only a subset of African genetic variation. As they spread across the world, that limited variation got spread even thinner through what geneticists call serial founder effects. Each new region was colonized by a small group from the previous region, further reducing diversity with each expansion. Meanwhile, back in Africa, human populations continued evolving along multiple paths. Different groups adapted to different environments. They developed different technologies, different social systems, different cultural innovations. The Sand people of southern Africa developed clicking languages and became master trackers in desert environments. The Nile Valley civilizations learned to harness flood agriculture and build complex states. West African populations domesticated crops and developed ironwork technologies. Africa wasn't static after the out of Africa migration. It was a cauldron of innovation containing more human diversity, more cultural variation, more evolutionary experimentation than anywhere else on Earth. But the people who left carried something important with them. They carried the same fundamental human capacities that had evolved in Africa. The same cognitive flexibility, the same capacity for language and symbolic thinking, the same ability to innovate and adapt. Those migrants weren't somehow superior to the populations that stayed. They weren't more advanced or more intelligent. They were just humans carrying human abilities into new environments, and those new environments would shape their descendants. In unexpected ways. Because here's the thing about evolution. It never stops. Those small populations that left Africa encountered environments radically different from anything their ancestors had experienced. Frozen tundras, dense forests, high-altitude plateaus, island ecosystems. Each environment created new selection pressures, new challenges that required new solutions. Over thousands of generations, small physical differences accumulated. Skin pigmentation adapted to different levels of UV radiation. Body proportion shifted to match different temperature regimes. Immune systems adjusted to local diseases. Digestive systems adapted to local diets. But these were all superficial changes, tweaks to the basic human template. Underneath, we all remained fundamentally the same species, still carrying the marks of our African origin, still sharing the vast majority of our DNR with every other human population. We're all cousins, all descended from those African populations that existed 70,000 years ago. Some of our ancestors left and encountered new environments. Most stayed and continued the human story in the place where it began. The question isn't why Africans and Europeans are different. The question is why a small group of African migrants evolved slightly different physical traits after leaving the continent while retaining all the fundamental characteristics that make us human. And to answer that question, we need to understand what those migrants encountered when they left, because the world beyond Africa was about to present challenges unlike anything humans had faced before. Now here's where things get really interesting. Because after that bottleneck, after the three-way split that created modern humans, Neanderthals, and after all that evolutionary pressure and adaptation, you'd think every human population would have roughly equal chances at development, right? They all had the same basic genetic toolkit, the same cognitive abilities, the same capacity for innovation, but they didn't develop equally, not even close. And the reason has almost nothing to do with the people themselves and everything to do with the ground they were standing on. Picture two farmers, both equally intelligent, equally hardworking, equally motivated. Give one of them rich flat soil, with reliable rainfall and easy access to rivers. Give the other rocky mountainous terrain with unpredictable weather and no navigable waterways. Come back in 1,000 years. Whose descendants do you think will have larger, more complex civilizations? The answer is obvious. But for most of human history, we got the explanation backwards. We looked at the differences in outcomes and assumed they reflected differences in the people. We invented elaborate theory about racial superiority, cultural advantages, even divine favor, all to explain something that was actually much simpler and much more random. Geography, pure blind accidental geography. In the 1990s, a scientist named Jared Diamond noticed something that should have been obvious but somehow wasn't. He looked at a map of the world and realized that the continents don't just differ in size and location, they differ in something far more fundamental. Their orientation. Eurasia, a massive landmass stretching from Portugal to Korea, from the Arctic to the Indian Ocean, it runs east to west. It's long and wide, covering roughly similar latitudes across its entire span. Africa, on the other hand, runs north to south. It's tall and narrow, stretching from Mediterranean climates through tropical zones to temperate regions at the southern tip. Why does this matter? Because latitude determines climate, and climate determines what you can grow, what animals can survive, what technologies work. When a continent runs east to west, innovations can spread easily. A farmer in Turkey discovers that wheat grows well in their climate. That same wheat will probably grow just fine in Italy or France or China because they're all at roughly the same latitude with similar temperatures and seasonal patterns. But when a continent runs north to south, that same innovation hits walls. A crop that thrives in Mediterranean North Africa probably won't survive in the tropical rainforests of Central Africa. A farming technique developed in temperate South Africa won't necessarily work in the Sahel. You have to reinvent everything, adapt everything, essentially start from scratch as you move between climate zones. This is the axis theory, and once you see it, you can't unsee it. Eurasia, with its east-west orientation, was essentially one giant highway for ideas, crops, animals, and technologies. A breakthrough in the Middle East could reach China. A domesticated animal from the Asian steppes could end up in Europe. Knowledge moved like water flowing downhill, following the path of least resistance across similar environments. Africa didn't have that advantage. The Sahara Desert, the largest hot desert on Earth, cuts the continent almost in half. It's not just big, it's hostile, expanding and contracting with climate cycles, but always presenting a massive barrier to movement. For most of human history, crossing the Sahara was incredibly dangerous. Caravans needed specialized knowledge, specific animals, and extensive preparation. Many didn't make it. But even without the Sahara, Africa's geography creates challenges. Below the desert, you hit the Sahel, a semi-arid transition zone. Below that, tropical savas, then equatorial rainforests, hot, humid, dense with vegetation and disease, then more savanna, then subtropical zones. Finally, temperate regions at the southern tip, Each zone has different rainfall patterns, different soils, different diseases, different everything. An innovation that works in one zone might be completely useless in the next. The cassava that feeds millions in tropical regions won't grow in the Mediterranean north. The wheat that thrives in temperate zones can't handle equatorial heat. You can't just take your farming knowledge and move it 500 m south. You have to adapt, experiment, sometimes start completely over. Compare this to someone living in, say, ancient Mesopotamia. They develop wheat agriculture. Within a few centuries, that wheat is growing in Egypt, Anatolia, Greece, Iran, eventually making it to Europe, India, and China. Same crop spreading across thousands of miles because the latitudes are similar enough that the plant doesn't care where it's growing. Or take horses domesticated somewhere on the Eurasian steppes around 4000 BCE. Within 2,000 years, horses have spread from Spain to China. They revolutionized transportation, warfare, agriculture everywhere they go. Not because Eurasian people were smarter or more innovative, but because horses could survive and thrive across the entire temperate band of Eurasia. The climate was similar enough that the same animal bred for the same purposes worked everywhere. Africa had zebras, and zebras, despite thousands of years of attempts, were never successfully domesticated. Not because Africans weren't trying hard enough, but because zebras are fundamentally different animals with different temperaments. But even if they had been domesticable, getting them to spread across Africa would have been a nightmare. Zebras adapted to savanna climates wouldn't necessarily thrive in tropical forests or Mediterranean regions. Then there are the rivers. Rivers are civilization's highways, especially before roads and railroads. They move goods, connect communities, enable trade. Eurasia is crisscrossed with have navigable rivers. The Danube, the Rhine, the Volga, the Yellow River, the Yangtze, the Ganges. These rivers and their tributaries create vast networks where boats can move people, goods, and ideas across thousands of miles. Africa has rivers too. The Nile, the longest in the world. The Congo, second largest by volume globally. The Niger, the Zambezi. But here's the problem. They're not easily navigable for long distances. Waterfalls, rapids, seasonal variations in water level. The Congo has rapids that make much of it impossible. The Zambezi has Victoria Falls. The Nile has multiple cataracts that interrupt navigation. Even the Niger makes a strange bend that confused European explorers for centuries. These geographic barriers didn't make development impossible. Africa developed remarkable civilizations, sophisticated agricultural systems, complex trade networks, the Kingdom of Kush, the Mali Empire, Great Zimbabwe, the Swahili city-states. But each had to solve problems locally, often independently. Knowledge moved slower. Technologies couldn't spread as freely. And here's what makes this even more significant. Isolation is a double-edged sword. On one hand, it protects. Diseases that devastate one region might never reach another. Invasions that destroy one kingdom leave others untouched. Isolated populations can develop unique innovations suited to their specific environments. But isolation also limits. When farmers in Mesopotamia developed the plow, it spread across Eurasia within centuries. When metalwork techniques improved in Anatolia, they reached Europe and Asia within generations. Every innovation became available to vast populations, each of which could refine it, improve it, adapt it. Progress compounded. In Africa, innovations often stayed local longer, not because people were less creative or less communicative, but because moving ideas between radical. Why different climate zones is harder. A farming technique that works in the Ethiopian highlands might need complete redesign for the West African rainforest. By the time you've adapted it, someone else might have invented something completely different for their environment. The coastlines matter, too. Europe has an incredibly convoluted coastline with countless natural harbors, peninsulas, and islands. This encouraged maritime trade from early in human history. The Mediterranean connected dozens of civilizations, creating a vast network of exchange. The Atlantic coast, the North Sea, the Baltic, all fostered seafaring traditions and trade networks. Africa's coastline, relative to its size, is remarkably smooth. Fewer natural harbors, fewer protected bays. Much of the coast is surf-pounded beach, difficult to approach safely in primitive boats. There are exceptions, the Red Sea coast, the Swahili coast, where maritime trade with Asia flourished. But overall, Africa's geography didn't encourage the same maritime connections that developed around Europe and Asia. None of this means development was predetermined, or that some continents were doomed and others destined for success. It means the playing field wasn't level. Some regions had geographic advantages that accelerated certain types of development. Other regions faced geographic challenges that required different solutions, often more innovative solutions, but solutions that didn't necessarily lead to the same outcomes. Think about it like this: you're playing a video game where resources and technology spread faster in some directions than others. In some parts of the map, every innovation you discover instantly becomes available to neighboring players, and theirs become available to you. In other parts, you're mostly on your own, solving problems independently. Both groups might be equally skilled, but after a thou sand turns, the group with easier sharing will probably have accumulated more total innovations simply because they're benefiting from a larger network of contributors. That's essentially what happened in human history. Eurasian civilizations could pull innovations across vast areas. African civilizations often had to innovate in smaller, more isolated networks. Neither group was smarter or more capable. They were just playing on different difficulty settings. And here's the really crucial part. These differences weren't obvious to people living through them. A farmer in ancient Egypt didn't think, well, if only we had an east-west continental orientation. A chief in ancient West Africa didn't realize that navigable rivers were giving some distant civilization thousands of miles away a development advantage. They just dealt with their local reality, solved their local problems, built their local societies. But over centuries and millennia, these small geographic advantages and disadvantages compounded. They created different population densities, different agricultural surpluses, different capacities for supporting non-farming specialists, different rates of technological innovation. Not because of anything inherent in the people, but because of the ground they were standing on and the ease with which they could connect with other groups facing similar challenges. The geography lottery, it's random, it's powerful, and for most of human history it was invisible. But once you see it, everything else starts making sense. Here's a puzzle that explains more about world history than almost anything else. The animal question. Why Europe had horses and Africa had zebras. Take two animals. Both are large, powerful, striped equines. Both live in herds. Both have been around for millions of years. One of them, the horse, became humanity's most important partner, revolutionizing agriculture, warfare, and transportation. The other, the zebra, despite thousands of years of human effort, was never successfully domesticated, not by the ancient Egyptians, not by the Romans, not by anyone. Why? Because zebras are, to put it simply, terrible. They bite and don't let go. They have a ducking reflex that makes them nearly impossible to lasso. They get more aggressive as they get older, not more docile. And unlike horses, which have clear herd hierarchies that humans can exploit, zebras have egalitarian social structures. There's no lead zebra to control, no dominance pattern to hijack. They're essentially 500-pound sociopaths with hooves. But here's what makes this more than just an interesting animal fact. This difference, this accident of evolutionary biology, helped shape the entire trajectory of human civilization. The continents where humans evolved didn't just differ in their geography or climate. They differed fundamentally in something far more important: the animals that lived there, and specifically, which of those animals could be domesticated. In the entire history of humanity across all continents and all cultures, only 14 species of large mammals were ever successfully domesticated. 14 out of hundreds of large mammal species that humans encountered. That's a success rate of less than 5%. And those 14 species weren't distributed evenly across the world. 13 of them were found in Eurasia. 1, the llama, in South America. Africa, despite having the most spectacular collection of large mammals on Earth, contributed exactly zero to humanity's domesticated animal portfolio. Think about what Eurasia had. Horses for transportation and warfare, cattle for plowing milk and meat, pigs for converting waste into protein, sheep and goats for wool, milk, and meat, water buffalo for rice paddies, camels for desert transportation, even chickens which gave you egg, GSS, and meat with minimal resources. This wasn't just good luck. This was the biological equivalent of winning the lottery multiple times. Each of these animals provided something unique and essential. But more importantly, they could all be domesticated, using the same basic principle. Find the dominant animal in the herd, control it, and the rest follow. Now look at Africa. Lions, absolutely not. Leopards, good luck. Elephants. African elephants, unlike their Asian cousins, were never truly domesticated. They've been tamed, trained for specific tasks, but never bred in captivity, in a systematic way. They don't have the right social structure. Cape buffalo, notoriously aggressive, killed more hunters than any other African animal. Hippos, 3,000 pounds of territorial rage that kills more people annually than any other large African animal. And zebras, which look so tantalizingly similar to horses that humans kept trying to domesticate them for thousands of years, never submitted. This wasn't because Africans were less innovative or less desperate for domesticated animals. It was because the animals themselves were fundamentally different. African megapora had evolved alongside humans for millions of years. They knew us. They'd learned through evolutionary time that humans were dangerous. When your ancestors spent 2 million years hunting these animals with increasingly sophisticated weapons, the animals that survived were the ones that ran from humans or fought back viciously. Natural selection created an entire continent of large mammals that wanted nothing to do with us. Eurasian animals didn't have that advantage. Humans arrived in Europe and Asia much later after leaving Africa. These animals hadn't evolved with humans. They didn't have the genetic memory of being hunted by increasingly clever bipedal predators. They were naive, and that naivety made them domesticable. Ute domestication required more than just naive animals. It required specific traits. An animal suitable for domestication needed a flexible diet, so it wouldn't compete with humans for food. It needed to breed in captivity. It needed relatively fast growth rates, so you didn't have to wait 15 years for your investment to pay off. It needed a calm disposition, or at least one that could be bred toward calmness over generations. And crucially, it needed a social structure with clear dominance hierarchies. Horses had auras. A lead-made dominant stallion controlled the herd, controlled them, and you controlled the entire group. The same was true for cattle, sheep, goats, pigs. Even chickens had pecking orders that humans could exploit. But zebras, despite looking almost identical to horses, had none of it. Their social structure was loose and egalitarian. Their disposition remained aggressive, even after generations of attempted breeding. Their flight response was so hardwired that even hand-raised zebras would bolt unpredictably. The ancient Egyptians tried. They really tried. Wall paintings show zebras being led on ropes, but led is all they ever were. Never ridden systematically, never used for plowing. The Romans, who successfully imported and trained African elephants for warfare, couldn't crack the zebra problem. In the 1800s, European colonial administrators tried again, thinking modern techniques would succeed where ancient methods failed. They failed too. There's a famous photograph of a zebra pulling a carriage in colonial Africa, often cited as proof of domestication. What the photograph doesn't show is that this was a publicity stunt involving one peculiarly docile individual. It wasn't replicable. It didn't represent a breakthrough. And this mattered more than almost anything else because draft animals didn't just make farming easier. They revolutionized it, completely. A farmer with an ox-drawn plow could cultivate 10 times as much land as a farmer working by hand, maybe more. This meant surplus. Not just enough food to survive, but enough to support non-farmers, craftspeople, soldiers, priests, administrators, inventors. Civilization, in the form of cities and states and empires, requires agricultural surplus, and agricultural surplus at the scale needed for true civilization requires draft animals. Europe and Asia had them. Africa, for the most part, didn't. This wasn't a small disadvantage. This was foundational. When you can't plow efficiently, you can't generate the surplus needed to support specialized labor. When you can't transport goods efficiently, trade networks stay small and local. When you have no cavalry, warfare remains personal and small-scale, rather than strategic and territorial. The entire trajectory of technological and social development bends toward different outcomes, but the animal question didn't stop at agriculture and transportation. It extended into something far more sinister: disease. Every domesticated animal is a potential disease reservoir. Cattle gave humans measles and tuberculosis. Pigs gave us influenza. Horses gave us the common cold. Chickens gave us various flu strains. Living in close proximity with animals for thousands of years, Eurasian populations were constantly exposed to animal pathogens. Most people died, but some survived, and those survivors passed on genetic resistance to their children. Over dozens of generations, Eurasian populations developed immunity to a whole suite of diseases that originated in their domesticated animals. They paid for this immunity with millions of deaths over thousands of years. Children dying of smallpox and measles generation after generation, until finally, the population as a whole carried enough genetic resistance that these diseases became survivable childhood illnesses rather than population-destroying plagues. This was a terrible price to pay, but it was paid gradually over millennia, allowing populations to recover between outbreaks. Africa, with far fewer domesticated animals, never developed this immunity. Neither did the Americas, which had only llamas and alpacas. Neither did Australia, which had no domesticated animals at all. When Eurasians finally made contact with these populations, they brought with them not just superior military technology made possible by horses and metal weapons, but an invisible arsenal of pathogens. Diseases that were merely unpleasant for Europeans. Smallpox that you got as a child and recovered from were absolutely devastating to populations that had never encountered them before. This is why when Europeans arrived in the Americas, diseases killed 90% or more of the indigenous population before warfare even began. This is why African populations, despite having some resistance to tropical diseases that devastated Europeans, still suffered massive mortality when exposed to Eurasian disease packages. The animal question wasn't just about who had better farming. It was about who had survived enough animal diseases to become walking biological weapons. Now you might be thinking, surely humans could have just moved animals around. Why didn't Africans import horses? Some did. Horses reached North Africa early and thrived in some regions, but they couldn't survive everywhere. Tsetse flies, which carried trypanosis, sleeping sickness, made large parts of sub-Saharan Africa deadly for horses and cattle. The fly didn't bother zebras or buffalo, which had evolved alongside it. But imported Eurasian animals died quickly. Even when horses could survive, they required infrastructure, fodder, breeding programs, specialist knowledge, all of which required the agricultural surplus that you needed horses to create in the first place. A circular problem with no easy solution. The same was true in reverse. Europeans couldn't effectively use African animals even when they tried. Zebras remained uncooperative. African buffalo were too dangerous. The animals and the civilizations had co-evolved. You couldn't just swap them around and expect the same results. So, here's what the animal question created. Two parallel human stories developing on different continents with fundamentally different resource bases. In Eurasia, humans harnessed animal power for agriculture, transportation, and warfare. This generated surplus, which supported cities, which enabled specialization, which accelerated technological innovation. A compound interest of civilization kicked in. Each generation built on the last. Writing systems emerged to track agricultural surplus. Mathematical systems developed to calculate taxes and manage trade. Military technologies advanced rapidly when cavalry became central to warfare. Metallurgy progressed when you had the agricultural surplus to support full-time blacksmiths. In Africa, humans adapted brilliantly to what they had. They developed sophisticated systems of agriculture. Without draft animals, they created extensive trade networks on foot and by boat. They built impressive states and kingdoms but they were doing it with one hand tied behind their backs.
Every achievement required more human labor, more time, more energy. The compound interest of civilization accumulated more slowly.
And then, when these two worlds finally collided in the age of exploration, the gap had become enormous, not because of any inherent difference in human capability, but because 10,000 years of history had played out with different animal partners. The Eurasian advantage in domesticated animals had cascaded through every aspect of civilization: agriculture, transportation, warfare, disease resistance, even political organization. All of it traced back, at least partially, to those 14 domesticated species, 13 of which happened to live in Eurasia. It's almost embarrassing how much of human history comes down to this. Not great leaders, or brilliant innovations, or cultural superiority, but which continent happened to have animals with the right temperament and social structure to be domesticated. Africa had magnificent wildlife, the most spectacular collection of large mammals on Earth. But they were the wrong magnificent wildlife, and that climate and disease, the invisible shapers of history, made all the difference. Now, let's talk about something that shaped human history more than any war, any king, any empire. Something invisible, something that operated at the scale of continents and millennia: climate and disease. The twin forces that decided which human populations could grow, large and which would stay small, which societies could build cities, and which remain mobile, which civilizations would dominate, and which would struggle. And here's the thing nobody wants to say out loud. Africa got the worst deal imaginable. Not because of anything Africans did or didn't do, but because of geography, biology, and sheer terrible luck. Start with the climate. Europe sits roughly between 35 and 60 degrees north latitude. Temperate zones, 4 distinct seasons, predictable rainfall patterns, winters cold enough to kill off many disease-carrying insects, but not so cold that agriculture becomes impossible. Summers warm enough to grow crops reliably, but not so hot that outdoor work becomes dangerous. Africa straddles the equator. The tropical and subtropical regions where most Africans lived were something else entirely. Year-round heat, humidity that could reach 90%, temperatures that regularly exceeded 35 degrees C, 95 Fahr. This isn't just uncomfortable. It fundamentally changes everything about how human societies can develop. Let's start with agriculture. Growing food in tropical Africa was harder than almost anywhere else on Earth. Not impossible, obviously, people managed it, but drastically more difficult than in temperate zones. The problem starts with the soil. Counterintuitively, tropical soils are often terrible for agriculture. All that rain and heat, it leaches nutrients out of the soil faster than they can accumulate. In temperate Europe, winter freezes slow down decomposition. Organic matter builds up in the soil, creating deep, rich, nutrient-dense topsoil. That's why European and North American farmland is so incredibly productive. Centuries of leaf fall and plant decay, creating layers of fertility. In tropical Africa, decomposition happens so fast that nutrients barely have time to accumulate before they're washed away or broken down. You get thin topsoil over hard clay or laterite, plant something and you might get a good harvest the first year, maybe the second. By the third year, the soil is exhausted. You have to move to new land. Let the old plots regenerate for a decade or more. This created a fundamental constraint on population density. In Europe, you could farm the same fields for generations, even centuries, if you managed them properly. Population could concentrate in villages and towns. Specialization could develop. In much of tropical Africa, you needed vast territories per person because agriculture had to be shifting and extensive rather than intensive. But it gets worse. Food storage. In temperate climates, you harvest in summer and fall, then store food through the winter. Cool, dry conditions, perfect for preservation. Grain could be stored for years in a well-built granary. This meant you could accumulate surpluses, feed specialists who didn't farm, support armies, priests, administrators, craftspeople. In tropical climates, there is no winter. Heat and humidity year-round create perfect conditions for spoilage. Grain stores rot within months. Insects infest everything. Mold grows on food stocks with terrifying speed.
Some African societies developed clever preservation techniques, drying, smoking, fermentation, but nothing could match the storage capabilities of temperate civilizations. This meant African societies had a much harder time supporting large urban populations or maintaining standing armies for extended periods. You couldn't stockpile food for lean years. You couldn't feed large numbers of non-farming specialists. Every harvest had to be consumed relatively quickly, leaving little room for the kind of surplus accumulation that funded civilization building elsewhere. Then there's the sheer metabolic cost of living in tropical heat. Your body has to work constantly to cool itself. Sweating burns calories. Increased heart rate and blood flow to the skin burn calories. Just existing in temperatures above 30 degrees C requires significantly more energy than living in temperate zones. This might not sound like much, but multiply across a whole population over generations. People in tropical climates need more food just to maintain basic function. They have less energy left over for intensive physical labor. They're more vulnerable to food shortages because they have smaller margins between adequate nutrition and starvation. European colonists noticed this and completely misinterpreted it. They saw Africans working less intensively than Europeans and concluded they were lazy. They didn't understand they were watching metabolic adaptation to heat. Work too hard in tropical heat without adequate hydration and cooling, and you die. European work patterns designed for temperate climates were literally unsuited to tropical conditions, but the climate challenges were nothing compared to the disease burden. And this is where Africa's evolutionary success became its developmental curse. Remember, humans evolved in Africa. We lived there longer than anywhere else. And so did our diseases. Malaria, sleeping sickness, yellow fever, river blindness, schistosomes, dozens of parasitic worms, bacterial infections that barely existed elsewhere. Africa had them all, and they had been evolving alongside humans for hundreds of thousands of years. Malaria alone was probably the single biggest check on African population growth in history. Caused by Plasmodium parasites transmitted by Anopheles mosquitoes, malaria creates cycles of fever, anemia, and organ damage. It kills children in enormous numbers. Even survivors often suffer cognitive impairment and developmental delays from repeated infections. The evolutionary response was remarkable. Sickle cell trait, where you carry one copy of the sickle cell gene but not two, provides significant protection against malaria. If you have one sickle cell gene, your red blood cells are hostile environments for malaria parasites. Natural selection favored this trait so strongly that despite its costs, carrying two copies causes sickle cell disease. It spread throughout malarial regions of Africa. This is evolution in action. Populations adapting to a disease environment so lethal that even a mutation with serious downsides becomes advantageous. But here's the cost. Sickle cell trait provides protection but not immunity. People still got malaria, still died from it, still suffered its debilitating effects. And the sickle cell disease that affected those who inherited two copies, brutal, painful, often fatal before adulthood. Similar adaptations occurred with other diseases. Duffy negativity, a blood group variant that provides protection against Viva K, malaria, became nearly universal in we. Stadium T deficiency, Egypt 6PD deficiency, despite causing problems of its own, spread because it offered some malaria protection. African populations were locked in an evolutionary arms race with their diseases. Adaptations piling on adaptations, each with its own trade-offs and costs. Compare this to Europe. Europeans face diseases too, obviously. Plague, smallpox, typhus, cholera, but with crucial differences. Most European diseases were acute rather than chronic. They killed you, or you recovered and gained immunity. Over centuries, European populations developed resistance through the survivors having children. Egypt epidemic left behind a population slightly more resistant than before. African tropical diseases didn't work that way. Malaria doesn't give you immunity. You can get reinfected hundreds of times. Sleeping sickness doesn't become less lethal with exposure. These diseases created a constant grinding attrition that never relented, never allowed populations to develop full immunity, never became less dangerous over time. Then there was the tsetse fly. This insect, barely the size of a housefly, created a barrier to development across huge swaths of Africa, more effective than any mountain range or desert. Jetsa flies carry tranosomes, parasites that cause sleeping sickness in humans and nana in livestock, and they made large areas of tropical Africa essentially uninhabitable for cattle, horses, and other domesticated animals. The Tsetse Belt covered millions of square kilometers of Central and West Africa. Any livestock brought into these areas died within months. This meant African societies in Tsetse regions couldn't use draft animals for plowing, couldn't use animals for transport, couldn't accumulate wealth in herds the way societies across Asia, Europe, and temperate Africa did. The agricultural implications were staggering. In Europe, a farmer with an ox-drawn plow, old cultivate 10 times more land than someone using hand tools. Animal power was the difference between subsistence, agriculture, and surplus production. Without it, African farmers in Tsetse regions were permanently limited to small plots worked by human muscle alone. The transport implications were equally severe. Without horses or oxmen, moving goods required human porters. This made long-distance trade expensive and limited. It made military campaigns difficult because you couldn't move supplies efficiently. It created natural barriers to empire building and economic integration. Some African societies adapted brilliantly. West African peoples developed Setz-resistant cattle breeds. East African pastoralists learned to live in borderlands between sets of zones and grasslands, moving seasonally to avoid the flies. But these were workarounds for a problem that fundamentally didn't exist in most of Eurasia. And here's where it all compounds. Tropical climate makes agriculture harder and food storage nearly impossible. Malaria and other diseases kill children and weaken adults. Tsetse flies prevent animal husbandry and transport across vast regions. Each problem makes the others worse. Low agricultural productivity means less surplus to buffer against disease. High disease burden means less labor for agriculture. Lack of transport animals means you can't compensate by trading for food from distant regions. Meanwhile, in temperate Eurasia, the opposite is happening. Good soils produce reliable surpluses. Effective food storage buffers bad years. Draft animals multiply agricultural productivity. Lower disease burden means more people survive to adulthood and contribute to society. Each advantage compounds the others. None of this made Africans less intelligent, less innovative, or less capable. The archaeological record shows African societies developing sophisticated technologies, complex political systems, impressive artistic traditions. But they were doing it while fighting with one hand tied behind their backs. Actually, both hands and weights on their ankles and someone constantly tripping them. The human populations that evolved in these challenging environments actually developed remarkable adaptations. Different body proportions for heat dissipation, more efficient sweating mechanisms, genetic variants that offer disease resistance. These were evolutionary innovations as impressive as any technology, but they were solutions to problems that temperate populations simply didn't face. By the time Europeans arrived in Africa with their guns and ships, they weren't encountering societies that had failed to develop. They were encountering societies that had been fighting a much harder battle for much longer. The difference in outcomes wasn't about capacity. It was about the invisible shapers of history, climate and disease, the forces that nobody controlled, but that controlled everything. Here's something nobody, the agricultural revolution, different crops, different destinies tells you about the agricultural revolution. It wasn't one revolution. It wasn't one revolution. It was dozens of separate revolutions happening independently across the world, each one shaped by what was growing in the ground when people decided to stop wandering and start planting. And the crops made all the difference. Picture yourself 10,000 years ago in the Fertile Crescent. That arc of land stretching from the Persian Gulf through modern Iraq and Syria to the Mediterranean coast. You're a hunter-gatherer, considering a radical lifestyle change. You're thinking about staying in one place, planting seeds, waiting for harvest instead of following game animals and seasonal plants. Now look at what's growing around you. Wild wheat, wild barley, lentils, chickpeas, peas. See aren't just any plants. They're absolutely perfect for agriculture. The seeds are large, packed with calories and protein. They grow quickly, often producing a harvest within months.
Most importantly, they're self-pollinating annuals. You don't need multiple plants to produce seeds. You don't need to wait years for a tree to mature. You plant in spring, harvest in summer, and the seeds store beautifully for months or even years without rotting. It's like finding an instruction manual for civilization just lying on the ground. These founder crops, as agricultural historians call them, had another crucial advantage. They were already halfway domesticated before humans even started trying. Wild wheat and barley had large seeds compared to most wild grasses. They grew in dense stands that were easy to harvest in bulk. Their genetic makeup meant that mutations for easier harvesting, larger seeds and better taste appeared frequently and could be selected for quickly. Within just a few thousand years, fertile crescent farmers had transformed these wild plants into the domesticated varieties that would feed empires. Wheat that held onto its seeds instead of scattering them in the wind. Barley that germinated predictably and grew in neat rows. Lentils that produced massive protein-rich harvests with minimal effort. The numbers tell the story. 1 acre of wheat could produce enough calories to feed a family for a year, with surplus left over. That surplus changed everything. Now travels south to Sub-Sahara and Africa, around the same period. Your ancestors are also transitioning from hunting and gathering to agriculture, but look at what they're working with. The crops are completely different. Sorghum, pearl millet, African rice, yams, tea coffee. These are impressive plants, incredibly well adapted to African conditions. Resilient, drought-resistant, nutritious, but they're also harder to domesticate and harder to store. Take sorghum, it's brilliantly suited to hot, dry conditions where wheat would shrivel and die. It can survive droughts that would devastate other crops. It produces nutritious grain that can be ground into flour. But wild sorghum is a nightmare to harvest. The seeds shatter easily, scattering before you can collect them. The plants grow irregularly, making systematic farming difficult, and domesticating it required selecting for dozens of traits simultaneously, a process that took thousands of years longer than wheat domestication. African rice, independently domesticated in the Niger River Delta, faced similar challenges. It was incredibly productive in wetland environments, but it required precise water management and grew best in specific ecological niches. You couldn't just plant it anywhere and expect results. Yams presented different problems. They're tubers, not grains, which means they provide plenty of calories, but don't store as easily. A bag of wheat seeds can sit in a dry warehouse for years. Yam starts sprouting or rotting within months. This makes long-distance trade harder and surplus accumulation more difficult. And here's the thing that really matters. It's not that African crops were inferior. In their environments, they were often superior. Sorghum and millet could grow in conditions that would kill wheat. Yams provided more calories per acre than most grain crops. African rice was perfectly adapted to the continent's river systems, but they didn't provide the same economic and social opportunities as the Fertile Crescent founder crops. Let's talk about what surplus food actually means for a society. When your farmers produce more fruit than they need to survive, magical things become possible. Not everyone has to farm anymore. In the Fertile Crescent, and later across Eurasia, the wheat and barley surplus, created a new kind of human being. The specialist, the person who didn't farm at all, but instead spent their days doing something else, making pottery, working metal, building houses, keeping records, organizing trade, leading armies, interpreting the will of the gods. This wasn't luxury. This was the foundation of complex civilization. You can't have professional soldiers if those soldiers need to spend half their time farming to eat. You can't have scribes developing writing systems if they're harvesting wheat 8 months a year. You can't have architects designing irrigation systems if they're tending their own fields. The storable grain surplus made specialization possible, and specialization made everything else possible. Within a few thousand years of agriculture, beginning in the Fertile Crescent, you had cities, real cities with thousands of inhabitants, most of whom never planted a single seed. They were fed by farmers who produced massive surpluses, stored in granaries distributed by an increasingly complex bureaucracy. Those cities became centers of innovation. When you put thousands of specialists in close proximity, ideas collide.
The potter learns something from the metal worker. The architect applies principles from the irrigation engineer. The priest astronomer, tracking the seasons for religious purposes, accidentally develops mathematics. Technology compounds. Each innovation builds on the previous one, and the speed of innovation is directly proportional to how many specialists you can support, which is directly proportional to how much surplus food your agricultural system produces. Now look at what happened in Africa. Agriculture developed independently in multiple regions. The Sahel region domesticated sorghum and pearl millet. West Africa domesticated yams and African rice. Ethiopia domesticated yams and African rice. Ethiopia domesticated tea and coffee. These were genuine agricultural revolutions. Human societies fundamentally transforming their relationship with food production. But the surplus was smaller. Those tuber crops didn't store as easily, limiting how much could be accumulated. The grain crops required more labor and produced less predictable yields. The specialists emerged more slowly. Cities developed certainly, but they appeared thousands of years later than in the Fertile Crescent, and generally remained smaller. This wasn't about intelligence or capability. African farmers were brilliant. The agricultural techniques developed for sorghum cultivation in unpredictable rainfall conditions were incredibly sophisticated. The irrigation systems built for African rice in the Niger Delta were engineering marvels. The soil management practices developed for yam cultivation showed deep understanding of ecology, but they were working with a different agricultural base, and that base imposed different constraints. Then there's the geography problem. Agriculture spreads fastest along lines of latitude across regions with similar climates and growing conditions. Wheat domesticated in the Fertile Crescent could be grown with minimal adaptation across the entire Mediterranean through Central Asia into Northern Europe. It's all roughly the same latitude with similar seasonal patterns and temperature ranges. The agricultural package: wheat, barley, lentils, plus domesticated sheep, goats, cattle, and pigs, spread across Eurasia like wildfire. Within a few thousand years, farmers in Spain and farmers in Western China were growing essentially the same crops and raising the same animals. Africa runs north to south. Different latitudes mean different climates, different growing seasons, different pests and diseases. Crops domesticated in the Sahel couldn't just spread south into the rainforest belt. Completely different conditions required completely different agricultural systems. Yams from West Africa wouldn't grow in the dry Sahel. Teff from the Ethiopian highlands needed specific altitude and temperature ranges. So African agriculture developed as a patchwork of regional systems, each brilliantly adapted to local conditions, but not easily transferred between regions. Knowledge and techniques spread more slowly. The compound interest effect of agricultural innovation worked at a different pace. And there's one more factor that historians are only recently beginning to fully appreciate. Africa had seti flies. These tiny insects carry tronosemesis, sleeping sickness in humans, nagana in cattle. They made vast regions of sub-Saharan Africa essentially impossible for cattle raising. No plowing with oxen, no milk, no reliable meat source that could be herded and managed. This meant African agriculture was more labor-intensive. Without draft animals, you couldn't plow large fields efficiently. Without cattle-based fertilization systems, soil management required different techniques. The agricultural surplus was necessarily smaller because producing it required more human labor. Compare this to Eurasia, where cattle, horses, and water buffalo provided both labor and fertilizer. A farmer with a plow team could work far more land than a farmer with just a hoe. The surplus per farmer was dramatically higher, which meant more specialists could be supported per unit of agricultural population. By 2,000 years ago, the consequences were visible across both continents. Eurasia had developed interconnected charcoal civilizations stretching from the Atlantic to the Pacific. Massive empires supported by wheat and rice surpluses. Professional armies, bureaucracies, artisan classes, merchant networks, writing systems, mathematical traditions, architectural innovations, all built on the foundation of storable grain surpluses. Africa had developed its own complex societies, certainly Great Zimbabwe, the kingdoms of the Sahel, the Aksumite Empire, but they were working with different agricultural foundations, facing different geographical barriers, and accumulating technological innovations at a different pace. None of this was predetermined by biology or intelligence. It was crops. It was geography. It was the accident of which plants happened to be growing where, when humans decided to start farming. Your ancestors didn't choose to domesticate wheat or sorghum, based on some rational calculation of which would lead to faster civilizational development. They domesticated what was available, what grew in their environment, what their knowledge and tools could handle. But those choices, or really those accidents of geography, echoed forward through millennia. They shaped everything that came after: the speed of technological development, the size of cities, the complexity of political systems, the capacity to support professional armies and bureaucracies. Different crops created different destinies. Not better or worse, just profoundly different. And those differences were compounding decade by decade, century by century, creating the divergent historical trajectories that would define continents for thousands of years. But the story of agriculture was just beginning. What happened next would multiply these advantages and disadvantages in ways nobody could have predicted. So, humans had figured out the rise of states and empires. Power concentrates differently. Agriculture. They domesticated animals, developed tools, built villages. But here's where things get really interesting. Because what happened next wasn't the same everywhere, not even close. Around the world, human societies were taking wildly different paths toward complexity. Some built massive empires that ruled millions. Others remained in smaller, more distributed political structures. And for centuries, historians looked at this divergence and drew exactly the wrong conclusions. They assumed the societies that built big centralized states were somehow more advanced, more intelligent, more civilized. They were wrong. What actually happened was that geography, disease, and sheer random chance created conditions where certain types of political organization became advantageous. And in many cases, the societies that didn't build massive empires weren't failing to innovate. They were actively choosing organizational structures that made more sense for their specific environments. But let's start with what actually did develop, because the historical record has been wildly distorted. When most people think of ancient empires, they think of Rome, Greece, Persia, China, maybe Egypt if they're historically literate. But Africa had empires that would have made Roman emperors jealous. Empires that most history textbooks somehow forget to mention. The Mali Empire at its peak in the 14th century controlled more territory than Western Europe. More importantly, it controlled the trans-Saharan gold trade, making it possibly the wealthiest state on earth. When Mansa Musa, the emperor of Mali, made his pilgrimage to Mecca in 1324, he brought so much gold that he accidentally crashed the Egyptian economy. He gave away so much gold in Cairo that it devalued the metal for a generation. Think about that. A single African ruler carried enough wealth to destabilize the economy of one of the world's most sophisticated trading centers. This wasn't some minor chiefdom. This was a superpower. The Songhai Empire that followed Mali was even larger, stretching across West Africa and controlling key trade routes that connected Sub-Sahara and Africa to the Mediterranean and beyond. Its capital, Timbuktu, wasn't just a trading center. It was one of the world's great universities, with libraries containing hundreds of thousands of manuscripts on mathematics, astronomy, medicine, and philosophy. In southern Africa, the Kingdom of Great Zimbabwe built stone cities without mortar, structures so impressive that early European archaeologists literally couldn't believe Africans had constructed them. They invented elaborate theories about lost white civilizations, rather than accept the obvious evidence that African engineers had mastered sophisticated construction techniques. In East Africa, the Kingdom of Aksum was a major trading power from the 1st to 8th centuries, minting its own currency and maintaining diplomatic relations with Rome and Persia. It was one of the first major kingdoms to officially adopt Christianity, and its influence shaped the entire region's development. And of course, Egypt, ancient Egypt, wasn't separate from Africa. Despite how it's often taught, it was an African civilization built by African people that dominated the Mediterranean world for 3,000 years. So, why don't most people know about these empires? That's a story we'll get to later. But the point is, Africa absolutely developed large-scale political organization. The idea that it didn't is historical fiction created to justify colonialism. But here's the question. If both Africa and Europe developed complex states and empires, why did they develop differently? Why did European state formation eventually lead to the specific kind of technological and military advantage that would prove so devastating in the colonial period? The answer once again comes down to geography, but not in the way you might think. Europe's geography created a very specific set of conditions. It's a relatively small continent divided by mountains, rivers, and seas into natural compartments. These barriers were significant enough to prevent any single empire from easily dominating the whole continent, but not so significant that trade and communication were impossible. This created what historians call a competitive multipolar system. Dozens of kingdoms, principalities, and city-states, all crammed into a relatively small area, all constantly competing for resources and territory. If you wanted to survive as a European state, you had to innovate militarily, economically, and politically, because there were always rivals right next door, ready to conquer you if you fell behind. This competition was brutal. Between 1500 and 1914, major European powers were at war something like 60% of the time. War wasn't the exception. It was the default state of European politics. This constant warfare drove a particular kind of innovation. States that could tax more efficiently, organize larger armies, and develop better weapons survived. States that couldn't disappeared. Over centuries, this selection pressure created increasingly centralized, bureaucratic, militarized states. Africa's geography was different. It's massive, 3 times the size of Europe, and its interior was harder to navigate. Fewer natural harbors, rivers, interrupted by waterfalls, vast deserts creating natural barriers between regions. This meant African states often controlled trade networks rather than continuous territories. The great African empires were frequently organized around controlling key routes: the gold trade, the salt trade, the trans-Saharan caravan routes, rather than holding every square mile of territory. This wasn't inferior political organization. It was different political organization adapted to different geographic realities. But it didn't create the same kind of intense, constant military competition that characterized Europe. There's another crucial factor: writing systems and how they were used. Now, Africa had multiple writing systems, in fact. Ancient Egypt's hieroglyphs, Ethiopia's Gay script, West Africa's various indigenous writing systems. But the spread and use of writing varied enormously based on environment and political structure. In Europe, writing became essential for state administration relatively early. The Romans built their empire on written law, written records, written communication across vast distances. When Rome fell, literacy declined dramatically. But the idea of writing as essential to governance never completely disappeared. As European states reconstructed themselves after Rome's collapse, writing became the foundation of bureaucratic administration, tax records, legal codes, military rosters, trade agreements. Everything was written down. This created a kind of institutional memory. Knowledge could accumulate across generations even when individual rulers were incompetent. More importantly, Europe's printing revolution in the 1450s created exponential acceleration. Suddenly, knowledge could be duplicated and distributed at unprecedented scale. A discovery made in Venice could be known in London within weeks. This created a kind of knowledge network effect. Information was building on information faster than ever before in human history. In Africa, writing systems existed but served different purposes in different regions. In Islamic West Africa, Arabic literacy was high among scholarly and merchant classes. The Timbuktu libraries proved African scholars were producing sophisticated written works on every subject imaginable. But in many African societies, knowledge transmission remained primarily oral. This wasn't because people were incapable of writing. Oral traditions can preserve information with remarkable accuracy across generations. In some ways, oral traditions create more democratized knowledge because everyone can participate, not just a literate elite. But oral traditions have one critical limitation: they don't scale the same way. A written document can be copied infinitely and transported anywhere. An oral tradition requires person-to-person transmission. It's more intimate, more personal, but slower to spread across large populations. and great distances. This affected how quickly certain types of knowledge could accumulate and compound. Technical innovations that might have taken generations to spread widely in societies, relying primarily on oral transmission, could spread in years in societies with widespread literacy and printing. There's also the question of population density and how it affected political organization. Agricultural surplus determines how many people can live in a given area without farming.
More surplus means more people can specialize in other activities, crafts, trade, administration, warfare. This allows for more complex political hierarchies.
Europe's domesticated animals and relatively productive grain agriculture supported high population densities in many regions. This meant states could extract taxes from large populations, support professional armies, and fund elaborate administrative bureaucracies. Parts of Africa achieved similar population densities. The West African empires, the Ethiopian highlands, the Great Lakes region. These areas developed comparable political complexity, but vast regions of Africa, particularly central and southern areas, had lower population densities due to disease burden, less productive indigenous crops, and environmental challenges. In these regions, large centralized states were often less advantageous and smaller, more flexible political structures. This doesn't mean these societies were less sophisticated. They were optimized for different conditions. A small mobile group can survive environmental shocks that would devastate a large settled population. Decentralized authority can be more resilient than centralized power when external threats are unpredictable. European observers arriving centuries later saw this decentralization and assumed it represented primitive political organization. They missed the point entirely. These were adaptive strategies, not failed attempts at empire building. And here's something that rarely gets discussed. Different concepts of wealth and power. European political philosophy, particularly after the Renaissance, became obsessed with territorial control and resource extraction. Wealth meant controlling land, mines, trade routes. Power meant the ability to mobilize armies and conquer territory. Many African political systems had different value frameworks. In some societies, wealth was measured in people, in relationships, in alliances. A powerful ruler wasn't necessarily one who controlled the most territory, but one who could mobilize the most followers, who had the most extensive kinship networks, who could broker the most marriages between powerful families. This creates different kinds of political structures, less focused on rigid territorial boundaries, more focused on networks of obligation and alliance. It's not better or worse, it's different. But when these different systems eventually collided during the colonial period, one was optimized for a very specific kind of competition, industrial warfare and territorial conquest, and the other wasn't. That difference would reshape the world, but we're getting ahead of ourselves. Before that collision happened, both continents were accumulating knowledge, building on the foundations their ancestors had laid. And that process of accumulation, that compound interest of human knowledge, was about to accelerate beyond anything anyone could have imagined. Technology and innovation, the compound interest of knowledge. Imagine you're watching a single spark fall into dry grass. On its own, it's nothing. Just a brief glow, then darkness. But if the grass is right, if the grass is right, if the wind is right, that spark becomes a flame. The flame becomes a fire. The fire jumps from tree to tree until suddenly the whole forest is burning. Human technology works the same way. No invention appears out of nowhere. Every tool, every idea, every scientific breakthrough is a spark dropped onto a landscape of older knowledge. If the landscape is ready, the spark catches. If it's not, the spark dies, and the invention disappears back into the dark. Think about the printing press. We like to imagine some lone genius in Europe suddenly deciding to make a machine that could spray words onto paper and change the world. But that simple machine was sitting on top of thousands of years of quiet innovation. To build a printing press, you need metallurgy advanced enough to cast durable, movable type. You need inks that cling to metal but release onto paper, You need paper itself made from plants using techniques carried from China through the Islamic world into Europe. And you need something even more invisible. You need people who can read. A printing press in a world without widespread literacy is just an expensive way to stamp shapes onto kindling. Only when all those underlying systems are in place does the press become a revolution. That's what technology really is. Not individual gadgets, but layers and layers of accumulated solutions, each one resting on the ones below, like stones in a pyramid. Once you see that, the story of Africa and Europe stops being about who was advanced and who was behind. It becomes a story about different pyramids, different foundations, different layers of knowledge, shaped by different environments and different needs. Take iron. For a long time, historians assumed that iron technology came from the civilized centers of the old world and slowly spread outward. But the archaeological record in Africa tells a different story. In several regions, especially around what is now Nigeria, Cameroon, and Central Africa, iron smelting appears incredibly early and incredibly sophisticated, possibly developed independently. Smelting iron is not like making a stone tool. You can stumble onto a sharp rock by accident. You don't accidentally build a furnace that reaches over 1,100 degrees. Music arrange airflow with carefully positioned bellows. Select the right O's and then refine out usable metal. That's planned experimental generational knowledge. African ironworkers became masters of this dark alchemy. They learned to build clay furnaces that could run for days, turning rock into metal and metal into tools, weapons, and ritual objects. Some traditions produced steel of remarkable quality, as good as or better than anything in Europe for centuries. In certain societies, blacksmiths were treated almost like magicians or priests, keepers of secret knowledge that held communities together. But technology in Africa didn't stop at the forge. Across the continent, people were building in stone, mud and wood with a sophistication often erased from simple narratives of tribal life. In West Africa, the city of Timbuktu grew into a major center of scholarship and architecture, its mud brick mosques and homes engineered to breathe in scorching heat and sudden rain. In the Savazan forest farther south, cities like Benin developed complex earthwork, walls, mows, and planned street systems. Far to the southeast, in the hills of what is now Zimbabwe, stone walls snaked and curved across ridges and valleys. Great Zimbabwe, with its soaring dry stone enclosures, was not just a pile of random rocks. It was a carefully engineered complex, its walls fitted without mortar, its passages designed to control movement, its towers rising as statements of power and identity. Medicine, too, followed its own logic. In tropical environments where parasites, bacteria, and viruses flourished, surviving meant learning the secrets of plants. African farmers cataloged leaves, barks, roots, and resins with an attention that would put some modern laboratories to shame. Healers experimented over generations, observing what cured, what calmed, and what killed. They learned how to use bitter alkaloids to treat fevers, how to combine plants to reduce toxicity, how to perform surgeries and set bones. Some of these traditions spread. Some remained local, encoded in songs, rituals, and apprenticeships. Knowledge survived not in printed books, but in living lineages of specialists. And then there was navigation. On the Atlantic and Indian Ocean coasts, African sailors read currents, winds, and stars. Swahili city-states along East Africa's shore became hubs of Indian Ocean trade. Their shipbuilders constructing sturdy vessels that could ride the monsoon winds to Arabia, India, and beyond. Far inland, desert peoples charted routes across the Sahara using stars, dunes, and ancient waypoints. They crossed one of the deadliest environments on Earth with caravans so large they looked like migrating cities. These were not people without technology. They were people whose technologies were tuned to their realities. But technologies don't just arise, they move. Ideas hitch rides on people, on goods, on stories. Some routes become superhighways for innovation. Others are winding footpaths, powerful but slower, more fragile. Across Eurasia, the Silk Road tied together a vast horizontal landmass with relatively similar climates. A technique invented in China could hop step by step through Central Asia, Persia, and the Eastern Mediterranean, each stop adding its own twist until it reached Europe in a form barely recognizable from the original. Paper, gunpowder, compasses, silk weaving, numerical systems, religious concepts, all traveled this way. Europe sat at the far western end of this network, a sink where ideas pulled. Africa's great trade arteries ran differently. North-south corridors tied the Sahara to the Sahel and the forest beyond. Trans-Saharan caravans carried gold, salt, ivory, books, people, and ideas between West Africa and the Mediterranean. On the eastern coastline, the Indian Ocean trade linked East Africa to Arabia, India, and Southeast Asia. Innovations moved along these lines too. Crops, artistic styles, religious texts, architectural techniques. But the Sahara was not an easy highway. It was a barrier crossed at great cost. The Indian Ocean was seasonal, its winds dictating schedules, and deep within the continent, some societies remained relatively isolated by vast forests, shifting rivers, or disease environments that made long-distance travel dangerous. In those remote zones, local technologies could become exquisitely adapted and yet remain largely unknown to outsiders. Isolation was a shield. It kept out invaders and epidemics, but it also limited the cross-pollination that turns a few sparks into a continent-spanning blaze. While Africa's network stitched together in long, sometimes fragile threads, Europe was undergoing a different transformation. After the fall of Rome, Europe fractured into a patchwork of kingdoms, duchies, city-states, and empires. This might sound like chaos, and in many ways it was, but politically fragmented landscapes create a certain kind of pressure. Imagine dozens of neighboring states, all watching each other nervously, all vying for trade routes, land, and prestige. If one of them discovers a better way to build ships, cast cannon, or drill soldiers, the others have a choice. Copy or fall behind. If you lose that technological race badly enough, you don't just get conquered, you disappear. This is how competition becomes a kind of forced experiment. In Europe, naval technology exploded under this pressure. States bordering the Atlantic invested in better hull designs, more efficient sails, more accurate maps, small improvements in navigation tools, the astrolabe, the cross-staff. Eventually, the marine chronometer became the difference between bringing home a fortune in spices or never returning at all. Military technologies followed the same pattern. Gunpowder, an invention that had traveled from China through the Islamic world, met European metallurgy and state competition. Cannons grew more powerful. Fortifications evolved in response, spreading star-shaped bastions across the landscape. Firearms advanced from clumsy hand cannons to matchlocks, then flintlocks. Each step required chemistry, engineering, logistics. And beneath it all, organized systems of record-keeping and knowledge exchange, which brings us to one of the quietest but most powerful technologies humans have ever invented: writing. Writing turns language into matter. It lets a thought survive the death of the thinker, cross mountains, oceans, and centuries without relying on anyone's memory. When you write something down, you're not just saving information, you're building scaffolding for future information to climb. In Europe, the spread of writing and later printing created dense layers of this scaffolding. A mathematician in Italy could learn from a translated Arabic text that had itself preserved and expanded on Greek ideas. A mapmaker in Portugal could revise coastlines based on sailors' logs. A physician could read a textbook, compare it to observations, and annotate margins with corrections. Each generation didn't have to start from zero. They inherited libraries, literal and metaphorical, and added a little bit more. Africa had writing too. Hieroglyphs in Egypt, Gear script in the Horn of Africa, ancient Libico-Berber scripts in the north, Ajami writings where Arabic letters were adapted to record African languages, manuscript traditions in cities like Timbuktu and Jenners copied and commented on works of law, astronomy, medicine, and theology. But writing was not evenly distributed. In many regions, knowledge stayed primarily oral, embedded in stories, lineages, and rituals. Oral cultures can be astonishingly precise and complex, but they are vulnerable in a different way. Kill the storytellers. Break the chains of apprenticeship. and centuries of accumulated expertise can vanish in a single generation. Isolation mattered here too. Societies that were relatively cut off from large-scale conflict and long-distance trade could go centuries without the kind of intense competitive pressure that drove European states to pour resources into war fleets and printing presses. That wasn't a failure. In many ways, it was a success. Centuries of relative balance with local environments, but it meant their knowledge pyramids grew in different directions at different speeds with different strengths and weak points. By the time European ships began pushing aggressively into African waters, these asymmetries mattered. Europe's compound interest, unwritten, widely shared, often war-driven technologies met Africa's deep, but sometimes more localized, more orally transmitted, and differently worked expertise. One system had spent centuries optimizing for long distances, projection of power, by sea and cannon and letter. The other had optimized for survival in some of the harshest disease environments on Earth, for regional trade, for intricate social and ecological balancing acts. Neither path was inevitable. Both were products of geography, history, and countless individual choices made by people who, like you, woke up each day trying to solve the problems in front of them. Those different paths of innovation were about to collide, and when they did, the shock would reverberate across continents, bending the course of history in ways that are still shaping your life tonight, as you listen, thousands of years later. The colonial interruption, how history was violently redirected. The real divergence between Europe and Africa didn't start with evolution. It started with ships. For tens of thousands of years, the descendants of those bottleneck survivors had been experimenting with different ways of living. In Africa, dense networks of trade and scholarship stretched across the Sahara. In Europe, states were slowly forming, fueled by a particular mix of animals, crops, and geography. By the time we reach the last 1,000 years, the differences are no longer about bone structure or brain size. They're about something much more fragile: timing. By sheer historical accident, European societies happened to hit a technological takeoff. Gunpowder weapons, ocean-going ships, metal cannons, improved financial systems right around the same moment that African states were wrestling with their own internal pressures, climate shifts, and regional conflicts. The tiny geographic advantages Europe had been compounding quietly for millennia suddenly paid out all at once. Think of it like compound interest. Small early advantages in domesticable animals, in easily farmed grains, and densely packed farming communities had given Europe frequent disease epidemics, which sounds terrible and was. But it also meant a population with more immunity to those diseases. Stable surpluses had allowed more specialists, more soldiers, more inventors. Metallurgy advanced, navigation advanced, gun-making advanced. By the 1400s and 1500s, some European societies were standing at the S. Orlean with caravelle, cannons and compasses. On the other side of those waters were African societies that were sophisticated, politically complex, and deeply connected to global trade, but that had not specialized in building long-range ocean militaries or mass-reducing firearms. That mismatch would violently redirect history. At first, it didn't look like conquest. It looked like trade. European ships crept down the West African coast, stopping at established ports, negotiating with African rulers, buying gold, ivory, spices. But those same European states had a problem. Their newfound colonies in the Americas had land, they had sugar, they had tobacco, they had silver. What they didn't have was labor, at least not the kind they wanted to use. Indigenous populations were dying in horrifying numbers from diseases brought over from Europe and Africa, pathogens they had never encountered before. So European merchants went looking for a brutal solution. They found it on the African coast. The transatlantic slave trade did not begin as a simple story of Europeans capturing Africans everywhere they went. It started as a series of deals between European traders and certain African elites who saw an opportunity to strengthen their own positions against regional rivals, prisoners of war, people from enemy communities, against regional rivals, prisoners of war, people from enemy communities, those on the margins of social systems. These became commodities. But once the system was in motion, the logic of profit took over. The demand from the Americas was insatiable. Sugar plantations needed more workers. Mines needed more labor. European powers discovered that human beings could be treated as renewable raw material. So, the trade intensified. For 4 centuries, between 12 and 15 million Africans were shipped across the Atlantic. That number doesn't count the millions more who died during raids, marches to the coast, or the Middle Passage itself. No. Why does it count the unborn generations that vanished before they were even conceived? Imagine a continent forced to bleed. People decade after decade, century after century. Young men, young women, children taken during their most productive years. Entire regions destabilized as states shifted their economies from producing goods to producing captives. Warfare that had once been about land or honor or political disputes began to revolve around one goal: capturing human beings to sell to foreign ships. This is what historians mean when they talk about underdevelopment. It's not that Africa somehow failed to develop. It's that development was actively reversed, siphoned away. Skilled workers, farmers, artisans, metal workers vanished overseas. Political systems reoriented themselves around slave raiding and defense against raids. Communities fled inland, abandoning fertile coasts. Trust between neighboring groups frayed, replaced with suspicion and fear. Long-distance trade networks that had once carried gold and learning now carried chains. The slave trade was not just a moral catastrophe. It was a demographic and economic weapon. At the same time, Europe was doing something else. Those same ships that carried enslaved Africans to the Americas came back loaded with silver, sugar, tobacco, cotton. These commodities poured into European economies. They funded banks. They funded factories. They funded research. The wealth extracted from African bodies and American land fueled Europe's industrial revolution. So when we ask why Europe industrialized first, we can't just point to coal and rivers and clever inventors. We also have to point to stolen labor. Generations of human beings who should have been farming their own soil, building their own cities, inventing for their own societies, were instead forced to work under a foreign whip on distant plantations. This is where the geography, lottery, and the animal question turn into something darker. European advantages and guns, ships, and germs didn't just shape their own fate. They let them forcibly rewrite other people's histories, and nowhere was that more obvious than in the next phase, full-blown colonialism. By the late 1800s, the transatlantic slave trade was officially ending. But European powers had discovered something they liked even more than enslaved people. Land, rubber, gold, diamonds, copper, timber, palm oil, coffee, cocoa, groundnuts. Every resource that could be extracted from African soil became the target of a new scramble. Between 1884 and 1885, European leaders met in Berlin and without a single African representative present, drew lines across a map of Africa. Lines that ignored languages, cultures, trade routes, and existing states. Lines that would become borders. This was the colonial interruption in its purest form, an entire continent's internal evolution frozen, then forced into new shapes to fit someone else's economy. Pre-colonial Africa had empires, kingdoms, republics, stateless societies, city-states. There were tax systems, legal systems, irrigation projects, universities like Timbuktu, trade routes connecting the forest to the desert, to the Mediterranean, and the Indian Ocean. These systems had problems like all human systems do, but they were homegrown. They changed from within. Colonialism bulldozed that. European administrators dismantled or captured existing political structures and replaced them with indirect rule, direct rule, or settler governments designed with one overriding purpose: extraction. Railways were laid not to knit African economies together, but to move resources from mines and plantations to ports as efficiently as possible. Education, where it existed, was often shallow and aimed at producing low-level clerks, not inventors or industrialists. Factories that could have been built in Laos or Accra or Kinshasa were instead built in Liverpool, Manchester, and Marseille. Raw materials went out. Finished goods came in. African economies were locked into a one-way relationship where they supplied the basics and paid high prices for manufactured products made from their own resources. This wasn't a failure to industrialize.
It was a deliberate prevention of industrialization. Local industries that might have competed with European products were often discouraged, blocked, or simply starved of credit and infrastructure. And colonization didn't just redraw borders and rewrite budgets. It reached deep into people's minds. For colonial rule to work, Europeans had to justify it, not just to themselves, but to the people they were ruling. They built an entire ideology around it. They invented stories about African backwardness, primitiveness, childlike minds. They pointed to the very poverty and political instability their own interventions had caused as proof that Africans were somehow unfit to govern themselves. It was a neat trick. Break a system, then claim the brokenness was original. Schools taught African children European histories and European heroes, while their own histories were dismissed as myth or savagery. Local languages were downgraded. European languages became the gateways to power. Christianity and Islam, already present in some regions, were now often wielded in ways that attacked existing spiritual systems, labeling them pagan or superstitious. Over time, this created what psychologists call internalized inferiority. When a child grows up seeing their culture treated as a joke, their language sidelined, their ancestors portrayed as lazy or stupid, it leaves marks. Even after the colonial flags came down, those marks didn't disappear overnight. They linger in how people see themselves, in what gets funded and which histories are told in school and which are left out. And perhaps the most damaging narrative of all was the idea that European dominance represented some kind of natural destiny. That Europeans ruled because they were smarter, or more evolved, or inherently superior. That Africa was poor because Africans had done something wrong or failed to do something right. This is where our understanding of history gets twisted. If you zoom in on just the last 500 years, it can look like Europe was always ahead and Africa was always behind. But widen the lens and those assumptions fall apart. For most of human history, Africa was the center of the story. It was where our species began, where some of the earliest complex societies arose, where vast trade networks and intellectual traditions flourished. The colonial interruption compressed centuries of violence, extraction, and imposed underdevelopment into a brief, intense period that completely reshaped the global map. Then, after the damage was done, people tried to explain the new inequality by pointing to skin color, skull shape, or made-up categories of race. Biology was forced into the role of alibi. The truth is, quieter and stranger and more unsettling, Europe didn't conquer the world because Europeans evolved into a different kind of human. They conquered it because geography, disease patterns, animal distribution, and historical accidents gave certain societies an early boost in agriculture and technology. That boost snowballed into ships, guns, and empires. Those empires ripped people from their homes, tore up existing systems, and redirected development so that wealth flowed in one direction for centuries. The colonial period didn't just change borders. It changed what we think is normal. It made it seem natural that capital cities would be in Europe, that the best-funded universities and labor auras would be there, that modernity would be associated with pale skin and certain languages. It made it easy to forget that every human on Earth carries the same bottleneck genes, the same ancient survival toolkit, the same capacity for intelligence and creativity. When you lie down tonight and think about why Europeans and Africans ended up with such different recent histories, it's tempting to imagine deep biological gulfs. But the real gulfs were carved by ships and whips, by borders drawn in foreign capitals, by laws written in unforeign capitals, by laws written in unfamiliar languages, by a few centuries of violent redirection laid on top of 1,000,000 years of shared evolution. And even that is not the end of the story. Because once colonial rule began to crumble in the 20th century, something else began to happen. New nations emerged. Old cultures resurfaced. People started rewriting their histories, reclaiming their languages, challenging the myths that had been used to hold them down. To understand what those changes mean and what our bodies really say about who we are, we have to look more closely at the physical differences we see today. Not as hierarchies, but as footprints of adaptation to different environments. That's where we're going next.
Picture two people asleep side by side. Physical differences. Adaptation, not hierarchy. One has very dark skin, tightly coiled hair, long limbs. The other has very light skin, straight hair, a stockier build. If you froze that moment and showed it to someone from 200 years ago, they'd probably say you were looking at two different kinds of humans, two different races. But evolution tells a very different story. Not separate kinds, not higher and lower, just one species shaped in slightly different ways by different kinds of sunlight, different temperatures, different diseases, different foods. Adaptation, not hierarchy. Let's start with the most obvious difference our brains are trained to notice: skin color. Your skin is not a racial badge. It is a living, biochemical compromise between two opposing dangers. On one side, the sun, ultraviolet radiation, UV, is a kind of invisible damage. Too much of it shreds DNA, burns skin, and destroys a crucial nutrient called folate. Folate is vital for healthy pregnancies, sperm formation, and early fetal development. Lose too much folate, and birth defects, infertility, and miscarriages rise. For our ancestors living under brutal equatorial sun, that wasn't cosmetic. That was life and death. On the other side, the same sun, but now as a vitamin factory. Your skin needs UV to make vitamin D. Without enough vitamin D, bones soften, immune systems weaken, pregnancies get harder, and children's skeletons can twist and deform. For people living in places with weak sunlight, especially long winters with the sun low in the sky, every bit of UV was precious. So, evolution did what it always does when it faces a trade-off. It tinkered. The solution was melanin. Melanin is not a label, it's a molecule. Tiny packets of natural sunscreen inside your skin cells. They absorb UV, scatter it, and protect the vulnerable machinery underneath. In places where the sun is fierce and almost directly overhead year-round, like much of tropical Africa, selection favored more melanin. Darker skin acts like armor against UV overload. It protects folate, reduces skin cancer, and keeps the body's internal chemistry stable in a harsh light environment. In places where sunlight is weaker and more seasonal, like Northern Europe, that same armor becomes a problem. Too much melanin blocks too much UV. The vitamin D factory shuts down. Bones suffer. Pregnancies become riskier. So in those regions, generation after generation, individuals with slightly lighter skin had a small advantage. They could harvest more UV, produce more vitamin D, and leave more children. Over thousands of years, that advantage added up. Skin gradually lightened. But notice what's happening here. Evolution is not making a judgment. It's not saying dark is worse, light is better, or the reverse. It's doing math. How much UV is hitting your skin? How much folate do you need to protect? How much vitamin D can you afford to lose? Dark skin in the tropics is optimal. Light skin in the far north is also optimal. Intermediate shades in between are optimal for in-between places. If you move a dark-skinned population to Sweden for 1,000 generations, their descendants will likely evolve lighter skin. Move a light-skinned population to the equator, and over enough time their descendants will likely darken. Not because they became a different kind of human, but because the light changed, and their biology adjusted. Our skin tones are climate maps, not racial boundaries, and they're recent. Most of the evolution of very light skin in Europe, it seems to have happened in just the last 10,000 years after the spread of agriculture changed diets and vitamin D intake. That's only about 400 generations, less time than separates you from the first farmers who planted wheat in the Fertile Crescent. If human history was a 24-hour day, these pigment changes are in the last few minutes before midnight. Skin color looks deep and ancient, but in evolutionary time, it's practically brand new. Now zoom out from skin and look at the whole body. Why do some populations tend to be taller and slimmer with long arms and legs, while others are more compact and stocky? Biologists have noticed patterns here too, and they've given them names. Bergmann's rule and Allen's rule. Bergmann's rule says in a species that lives across different climates, individuals in colder regions tend to have bulkier bodies, more mass relative to surface area. Individuals in hotter regions tend to have more slender bodies, less mass relative to surface area. Allen's rule goes even deeper. In cold climates, limbs, arms, legs, fingers, ears tend to be shorter.
In hot climates, they tend to be longer. Why? It's all about heat. Your body is constantly trying to keep its core temperature within a narrow, safe range.
Too much heat loss in the cold, you die. Too little cooling in the heat, you also die. A short, wide shape with a lot of volume and not much surface area loses heat slowly. Think polar bear, or the stocky, barrel-chested bodies we often see in populations whose ancestors survived in freezing climates. A tall and narrow shape with long limbs has more surface area relative to its mass.
It's like a radiator, great for dumping extra heat. Not so great when it's 20 degrees for months on end. Many equatorial African populations show exactly this pattern.
Long legs, narrow hips, lean limbs, bodies tuned for shedding heat during long, hot days. Again, there's no value judgment here.
If you dropped a tall, heat-adapted equatorial hunter-gatherer into Ice Age Europe, with no clothes,
they'd freeze. Drop a short, compact, cold-adapted human into the hottest days of the cell with no shade or water, and overheating would be deadly. The body shapes weren't designed for beauty or status.
They were sculpted millimeter by millimeter for survival in specific temperatures.
And like skin color, these traits are flexible over time. You don't need millions of years for body proportions to shift. A few thousand years of consistent climate pressures, generation after generation, can tip the averages. Not in a clean, simple way. Evolution is messy, but strongly enough that the patterns become visible in bones and silhouettes. Yet for all these visible differences, skin, hair, noses, height, body shape, when geneticists look under the hood, something
startling appears. We're almost unimaginably similar. Two random humans, one from Europe and one from Africa, are likely to differ in only about 0.1% of their DNA. Out of 3 billion letters, maybe a few million vary. And the vast majority of those differences are shared across populations. They don't line up neatly with our folk categories of race. In fact, if you lined up all humans, you'd find more genetic variation inside Africa alone than in the rest of the world combined. That's because our species is older. There. Populations had more time to diversify before small groups left the continent and carried only a sample of that diversity with them. The labels we use, black, white, Asian, race, they're cultural inventions built on top of very small, gradual, overlapping biological differences. Differences that don't divide us into separate boxes so much as smear us across a continuous gradient. There is no gene for race. There is no sharp genetic boundary where African DNA stops and European DNA begins. What we see instead are shifting frequencies of certain variants. A skinned pigment gene, more common here. A cold adaptation variant, more common there. A malaria resistance gene clustering in regions with intense mosquito-borne disease. Populations, not races. Local adaptations, not separate kinds of humans. And many of these adaptations are vanishingly recent. The ability to digest milk as an adult in some European and East African groups that seems to have spread in just the last 58,000 years. Some high-altitude adaptations in Tibetans, possibly within 3,000 years. These are the newest chapters of our story, written while cities were already rising and empires forming. But the older, deeper chapters, the ones that came out of the ancient bottleneck, the ones that shaped our brains, our hands, our capacity for language and cooperation, those are shared by everyone. The genes that let you understand this story, the neural wiring that lets you imagine those ancient landscapes, the emotional circuitry that makes you care about strangers who lived 1 million years ago. Those are bottleneck gifts. Human gifts, not African, not European, just ours. So what do we do with this knowledge? We live in a world that has spent centuries trying to stack physical differences into a ladder. Dark at the bottom, light at the top, or sometimes the reverse depending on who is drawing the diagram. Always the same pattern. Take adaptation, turn it into hierarchy. But evolution doesn't build ladders. It builds trees, branches spreading in many directions, each one responding to the sunlight, the wind, the soil in its own environment. Dark skin is not a step down from light skin. It's a solution to a different level of UV radiation. A stocky,
compact body is not less evolved than a tall, willowy one. It's a thermal strategy tuned to a particular climate. Tightly curled hair, straight hair, wavy hair. Each of these has physical properties that interact differently with heat, sweat, and sunlight. Different does not mean better or worse. Different means adapted. When you walk through a city and see a crowd of faces, brown, black, pale, freckled, you're not seeing separate kinds of people.
You're seeing different answers to different environmental questions, all built on the same underlying blueprint.
The same oozed chromosome from that ancient bottleneck. The same capacity for language and memory and story. The same vulnerable brain that dreams, grieves, laughs, and wonders. If you stripped away the skin, the hair, the superficial cues our social brains latch on to, it would be almost impossible to tell who came from which continent just by looking at their genes. The differences we've built entire social systems around are a thin recent paint layer over a deep shared foundation. Tonight, as you drift towards sleep, you live inside one of those adaptations. Your skin, your bones, your lungs, your blood, all of them carrying faint signatures of the places your ancestors endured, the deserts they crossed, the winters they survived, the diseases they outran. Not to mark you as higher or lower, not to place you into a rigid biological caste, just to keep you alive in a particular patch of earth, long enough to pass your genes and your stories forward. When we remember that, the old myths about race start to dissolve. What's left is stranger and more beautiful. A single fragile species shaped by different suns, walking different paths across the same small planet, not ranked, not separated, just conclusion. The accident of geography and the unity of humanity adapted. So now when you look at a map of the world with Europe here, Africa there, Asia stretching off into the distance, you can see it a little differently, not as a picture of advanced and backward places, but as a frozen snapshot of a very long experiment. An experiment run by climate, coastlines, mountain ranges, rivers, and invisible armies of germs. Some lands got wide temperate plains, where wheat and barley could thrive. Others got deep tropical forests, where yams and oil palms were king. Some regions had big, easily domesticated animals, standing around in herds, horses, cattle, sheep, goats. Other regions had animals that were fast, nervous, too aggressive, or too few to ever be tamed. Some peoples lived in zones where diseases burned through populations again and again, quietly selecting for resistance over thousands of years. Others lived in colder climates where different threats shaped their bodies and their immune systems. The outcomes looked very different from the outside. Fortified cities and steel weapons in one place, complex oral traditions, herbal medicine, and deep ecological knowledge. In another, empires with writing and standing armies over here. Stateless societies with intricate kinship systems and consensus politics over there. To someone looking quickly centuries later, it was easy to confuse earlier access to certain tools with greater human worth. But when you trace the story back through the rise of agriculture, through the spread of animals and crops, through the invisible patterns of malaria and smallpox, back to the glacial pulses and shifting rain belts, back to the glacial pulses and shifting rain belts, back to that tiny population of survivors in Africa, you find something else entirely. You find that the real differences were never in human brains, or human hearts, or human potential. They were in the starting conditions who happened to live near wild wheat, who happened to share a continent with domesticable herd mammals, who happened to be on a landmass-oriented east-west, where crops could spread along. Similar latitudes who happened to be born into a zone of brutal diseases that quietly built up immune defenses over countless generations. Europeans did not become powerful because they were smarter. Africans did not remain largely non-industrial because they were less intelligent. Asians did not develop certain technologies first because they were more advanced. These are stories people told themselves later to make conquest and inequality feel inevitable, even natural. The deeper story is colder and stranger, but also more hopeful. Every person alive today descends from the same tiny ancestral population that survived that ancient bottleneck, the same fused chromosome, the same basic neural wiring, the same capacities for language, curiosity, cooperation, cruelty, creativity, and care. Over the last few hundred years, different groups were pushed in different directions by climate, geography, and disease. Skin darkened or lightened. Bodies became bulkier or leaner. Faces, hair, and height shifted. Immune systems specialized for local threats. But under all of that, the same blueprint remained. The same ability to invent tools when the world turned harsh. The same tendency to form families, tell stories, mourn the dead. The same drive to turn raw experience into knowledge and knowledge into power. When Europeans and Africans met in the last few centuries, it was not a meeting between superior and inferior peoples. It was a collision between societies with different geographic histories. One side armed with centuries of immunity to old-world diseases, gunpowder, steel weapons, and large domesticated animals. The other side armed with deep environmental knowledge, resilient social networks, and cultural traditions that had solved different problems. History recorded the clash. It often ignored the context. Understanding that context matters now because we live in a world still shaped by the aftershocks of those collisions. Inequalities that look like the result of culture or ability are often the long shadow of accidents. Where continents broke, where rivers ran, which plants could be tamed, which diseases took hold. If we can see that clearly, if we can recognize that no population is inherently superior, that the differences we see are mostly the imprint of environment on a single shared human nature, we gain something powerful. We gain the ability to tell a different story about ourselves. A story that doesn't excuse injustice, but also doesn't mystify it. A story that says these hierarchies were built. They can be unbuilt. These gaps were created by history. They can be narrowed by choice. The same human flexibility that once adapted us to ice ages, tropical forests, high plateaus, and desert coasts can now be turned towards something else. Building a future where the accident of where you're born matters less than what you are capable of, and where the knowledge of all civilizations is treated as a shared inheritance instead of a competition. So, as you drift towards sleep, imagine the planet in the dark. City lights scattered across continents, villages, towns, farms, deserts, forests, ships at sea, billions of people with the same ancient bottleneck in their DNA, the same deep history written in their cells, the same astonishing capacity to learn, to remember, to change. Europeans, Africans, Asians, Pacific Islanders, indigenous peoples of the Americas and Australia, not separate kinds of beings, but branches on one narrow, fragile tree that almost died before it really began. Almost, but not quite. If this journey through deep time and human history has kept you company tonight, you're invited to keep exploring. There are endless stories left about African kingdoms and European peasant villages, Asian maritime networks and American city-states, scientific revolutions and forgotten empires, quiet technologies, and loud invasions. Every region has a rich, intricate past worth knowing. If you'd like to hear more of them, you can gently tap like on this video and subscribe so you don't miss the next story. If you feel awake enough, you can leave a comment and tell us where in the world you're listening from, what patch of this tangled human map you call home. It's always fascinating to see how far these stories travel. And if you want to go a step further, you can choose to join our YouTube membership and support the channel directly. That's completely optional. These videos will always be here for anyone who needs a calm voice and a curious look at the past. But if you do decide to join, know that it helps us keep making content like this. Slow and thoughtful and a little bit different from the usual noise. For now, though, you don't need to do anything at all. You can just lay there, feeling the weight of your body, the rhythm of your breathing, knowing that in a very real sense, you're a miracle of survival, a descendant of people who endured ice, drought, famine, disease, and war, a carrier of genes shaped by deserts and forests and frozen plains, a member of a single global family that has been wandering and adapting and remembering for nearly 1 million years. Geography may have sent us down different roads. History may have told us we were separate.
But in the quiet underneath it all, we've always been one species, sharing one small world under one wide ancient sky. Rest well,